Sir. So in this class today, we are going to see about what is meant by time division multiplexing. Before getting into time division multiplexing, we need to know the concept what is meant by mux. The mux, what we will do is n number of inputs, one output based upon the signals. Here also dmux is one input based upon n outputs. So the mux costing less, and we have frequency division multiplexing. We use different frequencies because if all the signals are transmitted at same time and different frequencies, it's called frequency division multiplexing. Suppose when we try to use the same time and the different frequencies FDM, in time division multiplexing, all the signals operates at same frequency with a different time. Here we will include a time slot. So every time user will allocate it with a different time intervals. With that, we will just transfer this information. The user can take the control for fixed amount of time. In time division multiplexing, the data is not transmitted simultaneously. The data will be transmitted one by one as a frame. So every frames will form a time slots. In each and everything will be as a dedicated path. It will contain it and it will route from one node to another node. So you can use both in analog and digital. We have two types of time division multiplexing. One we call it as synchronous, another one we call it as asynchronous. In the synchronous time division multiplexing, it's a original time division multiplexing that accepts the input from the attached devices in the round robin fashion and transmit the data. So T1 and ISDN telephone lines are example for synchronous time division multiplexing. You can see this one sample outstream generated by synchronous out division multiplexing. So 1, 2, 3, 4 users are there. They just multiplex it. They can take it out. First bit, second bit has been sent. Like a third bit has been sent. Fourth bit has been sent. Like that, as a frame, you can send those information. If the devices generates data at the faster rate and the other devices, then the sample incoming data may take a time. So what we can do, we can add a buffer to increase our incoming data streams or anything. If a device has nothing to transmit it, we can simply insert a piece of data from the multiplex streams. So in these things, A has an capacity of sending more than twice a data. That two A's data has been sent, and one B and one DC has been sent. Again, two data has been sent in this particular thing. So another one, only data one from the system will send it. Other things doesn't have any information. So it has been demultiplexed. So synchronous time division multiplexing, you even have it alternate data can be sent it zeros and ones, and we can transfer those informations. So three types of popularly we use as TDMS, T1 multiplexing, ISDN multiplexing, and sonets. So T1 multiplexing continuous series where both digitalized and voice data has been used here. We can use that frames like nth T1 frame. Every frame has a channels and the channels has 24 channels. Each and everything has been separated by 64 kilobits per second. And we have the channels with the control bit and D bits. We have it and we just transfer those informations. So we have this one frames that frames can be taken over that path overhead. Every frames has 810 bits and that totally 6480 bits has been transferred. And it's very popular when we need a proper bandwidth for communications. So two stations out of 4 transmitting device, we can transfer those information. So wherever the data can be there, that alone also has been transferring, rest can be ideal. So every data source has been addressed, the statistical output has been classified. So if the data are also variables, like the length of the packets also can be included so that how much data has been transmitted, that will be known to the users. So it's more efficient bandwidth we need to use for statistical time division multiplexing. So overall, we have learned time division multiplexing, a different the time slot or anything that what we need a frame to transfer those informations. So the time has been there, kept it, and we have the frame slots, everything we transfer it. Synchronous time division multiplexing and asynchronous time division multiplexing has been noted.